This is lesson 2.6 out of the Rates, Ratios, and Statistics book. In my class, this starts on page 114, and lesson 2.6 is titled Motion Rates. All right, warm up. For this lesson, two story problems. All right, so Stan runs at 7 miles in 1 hour. Pat runs at 9 miles in 1.5 hours. 1.5. All right, which person runs at a faster rate? Okay, that's problem number 1 for your warm-up. Problem number 2. A berry farm charges $3 for 4 pounds of berries. How much will 12 pounds cost? Okay, how much will 12 pounds cost? All right, and then we have our I can statement for this lesson, what we will be learning. I can solve problems, compare and convert motion rates. That means rates dealing with motion, whether it's speed or distance, motion rates. All right, so you have 2 little note slips, and the first one we're going to use is the one called vocabulary, and we're going to put it in its usual space here. This will be a 2-page notes lesson. There's a lot to this lesson. I won't lie to you. There's a lot of writing we have to do, and it's going to take some time. This typically takes up my whole math period to teach this lesson, and we have our math lab time then to do the work. There's just a lot to it. The first part of it you pretty much know, but then it leads into some concepts that you don't yet know. So I'm just getting you prepared. All right. So vocabulary. The first one is motion rate. A motion rate is a rate that compares distance to time. That's pretty obvious. And then the next vocabulary is rate conversion. A rate conversion is a process of changing at least one unit of measurement in a rate to a different unit of measurement. And that's the part that's going to be new to you. We'll get to that on the second page, right? But right now we're going to be doing some work that really isn't all that unfamiliar to you. I'm going to take my red pencil and put a capital A in a circle to show that we're doing several examples in this lesson, and this is example A. All right, and we've got a word problem here we've got to write out. Our hands are just going to be cramped when we are done with this lesson. No way around it. Sorry. All right, so Gerald's family traveled at a rate of 55 miles per hour. If they traveled at this rate for 1.5 hours, how far did they drive? All right, so that's our setup. All right, step one, when we do a motion problem like this, step one is to locate in the problem, is to locate the unit rate. Okay, we're going to locate the unit rate. Well, the unit rate is 55 miles per hour. That's our unit rate. And I'm going to highlight that. 55 miles per hour. Okay, that's step one, locate that rate. Now, we're going to multiply it. Step two, we're going to multiply by how far they went. Or I'm sorry, for how long they were driving. So in this case, we're going to multiply by 1.5 hours. We're trying to find out how far they went. Okay. And so, if we do that, we've got 55 times 1 5/10, 1.5, which equals 82 5/10. 82 and a half, 82.5, right? Then the last step, step 3, is to answer the question. So in this case, the question is asking us, how far did they drive, right? So, Gerald's family traveled 82.5 miles. Okay, that's our answer. So that's how we do that problem. That's probably pretty easy. You've seen problems similar to that before, right? Okay, so now we're going to move on to the second page of our notes. Okay, the second page is on page 115. And with my red pencil, I'm going to put a capital B here for my example B. And we'll kind of start this off with a note that tells us what we're doing. So, you can use unit rates, remember what unit rates are, to compare motion rates, just like we did when we compared other rates in lesson 2.5. Alright, so we'll be comparing some motion rates now using unit rates. Alright, so we've got this long problem we need to write out. Alright, here we go. Kenna and Josh rode their bikes to the Circle K. I put Circle K there because the original problem from the book said they rode their bikes to the video store. Who goes to a video store anymore? I don't know. But they might go to the Circle K in their neighborhood. So, which is exactly the same distance from both their homes. Gee, what are the chances of that? I know. But this is how math problems are. So they both rode their bikes to the Circle K, which is exactly the same distance from both their homes. All right, now, Kenna traveled at a rate of 22 miles every 2 hours. Right? Josh traveled at a rate of 5 miles every 5/10 or 1/2 hours. 1/2 of an hour. All right. If they left at the same time, who arrived first? All right, there's our problem. All right, so, first thing we have to do is figure out what are our rates that we are going to compare. All right, the first one is, well, we've got Kenna here, who's traveling at a rate of 22 miles every 2 hours. So that's our first one. 22 miles every 2 hours. And then Josh, he traveled at a rate of 5 miles every half hour. That's our second rate we'll set up. Then we'll find the unit rates and compare. Okay? All right, so let's first look at Kenna. Kenna, 22 miles for every 2 hours. Now, to turn that into a unit rate, we need to make that 1 hour. That means we divide that by 2, top and bottom, and 22 divided by 2 is 11 miles. All right? That's how far that was Kenna's. Let's see. You know, I really should have. Let's do this. Make it stand out a little more. And then 11 miles. Whoops, I didn't mean that one. This one. 11 miles. All right, 11 miles. All right, so that's Kenna's rate. Now, let's take a look at Josh. Josh was traveling at 5 miles for every half hour. All right, and we need to turn that into a unit rate of 1 hour. So we divide by 1/2 or 0.5 divide by 0.5 top and bottom, and 5 divided by 0.5, that doubles that to 10 miles. All right, so if Kenna made it 11 miles in an hour and Josh made it 10 miles an hour, then who arrived there first? Who was going faster? Well, Kenna was going faster. Kenna arrived first. All right, she arrived first. All right, so then I'm going to take my light green pencil and draw a line underneath, and we're going to then take that second notes and put it here and talk about converting rates. All right, I told you there's a lot to this lesson. All right, so this is the last new skill for this lesson. All right, let's put that on there at this spot right here. Press it down and talk about what are our steps for converting rates. Okay, so converting rates. So step 1 for converting rates is to write the rate as a fraction. All right, well, that's what we've been doing all along. Figure out what the rate is and write it as a fraction. No big deal there. The second thing is to identify the units that you want in the answer. So you're converting from one set of units to a new, different set of units. So what are those units that you want in the final answer? You'll have to figure that out second. And then the next thing you'll do is multiply the original rate, that's the original rate they give you in the problem, by a conversion rate. That'll get you the units that you identified you want in step 2. I know, that sounds really confusing, I can only imagine. But it won't be as bad as I show it to you, I hope. All right, so with my red pen, I'm going to do a capital C. This is example number C in a circle. And here's the problem. Convert 9 feet per minute, 9 feet per minute to inches per minute. So we're converting feet per minute to inches per minute. All right. All right, so this is how it's done. Step 1, write out the original rate, the 9 feet per minute, right? Okay, so that is 9 feet per 1 minute, okay? That's your original rate. And then you're going to multiply that by some kind of multiplier that's going to get you to the rate they're asking you for, inches per minute, okay? So we don't know what this multiplier is yet. That's fine. That happens in step 3. But we set up the multiplied by some rate, we don't know yet, which equals the inches per minute that we want. So we don't know what the numbers are yet. Just pretend we don't care about the numbers. What we're thinking about right now is what are the units? Inches per minute. So they will be inches per minute. All right, now here's the thing. Remember when you're multiplying fractions, think way back to when we learned how to multiply fractions and how we could cross-reduce a fraction. So if I had a 3 in the numerator in one fraction and a 3 in the denominator of the other fraction, I could cross those two 3's out and make them a 1. And we called it, cross-reducing or cross-canceling. Well, we can do that with our units in this kind of a problem too. And that's what we're doing, because I have feet per minute here, and what I want to wind up with is inches per minute at the end. So which unit here do I want to get rid of? Well, I want to keep minutes because I want minutes in my final answer there. So it's feet that I want to get rid of. So how do I do that? I make sure that I have feet down here that I can get rid of. So 1 foot Okay, remember we've got to keep this as units, so it'll be 1 all the way across. So what equals 1 foot? This is inches here, so it's going to be inches there. Okay, so 12 inches equals 1 foot. Okay, and we canceled out the feet because we don't want them in our final answer. So now we have a setup where we have 9 times 12, which is 108. And so now it's 9 times 12 inches is 108 inches. And that's what we wanted, right? We wanted to get rid of the feet. We're converting the feet to the inches. So now since we canceled out those feet units, we've got 9 times 12 inches, which is 108 inches. And we've got 1 minute times 1 is 1 minute, right? So now we have converted the 9 feet per minute to inches per minute. So 9 feet per minute is equal to 108 inches per minute. All right? Okay, so I know there's a lot going on there, so we're going to do one more. All right, so let's put a capital D in a circle right here. And do that kind of problem again. Here we go. This one is going to be convert 2 feet per second, 2 feet per second to feet per minute. Feet per second to feet per minute. All right? Okay, so step 1, we set up the original rate, 2 feet per second. All right? So that's going to be 2 feet per 1 second. All right? Now, we got to multiply that by something to get us to our new rate, the feet per minute. We don't know what that is yet. That's fine. But what we want to identify right away is what are the units we want in our final answer. Feet per minute. So feet per minute. So now that we know what we want in our final answer, we can figure out, well, what are the units we need to get rid of? Okay? I want feet in my final answer. So it's seconds I've got to get rid of, right? So to get rid of seconds, I've got to cross cancel them. So seconds are going to be up here. So how many, and I have to keep this a 1 down here, right? So how many seconds, and this is the minutes, how many seconds in 1 minute? Well, I know that it's 60 seconds, right? And so I have crossed out these 2 units, and now I've got 2 feet times 60, which is 120 feet. And that's what I wanted, feet per minute, right? The second part. And now I have 1 times 1 minute is 1 minute. So 2 feet per 1 second is equal to 120 feet per 1 minute. All right? Okay, so a quick little note that we'll make down into the corner here. Get my red star over here. The thing to keep in mind when you're doing these conversions is what units do you want to get rid of? You got to get rid of the units you don't want in the final conversion. So let's write that over here. Get rid of the units you don't want. Okay, getting rid of the units you don't want in the final conversion answer. Okay, that's the key to keep thinking about when you're doing these setups. All right? Okay, so that's the notes. Let's take a look at our practice problems. Okay, these are the practice problems for lesson 2.6. We've got 3 of them. They're all very similar to what we did in our notes. So the first one here reads, Olivia's family traveled at a rate of 60 miles per hour for 2.5 hours or 2.5 hours. How far did they travel? Now this is very similar to the first example that we did in our notes. All right, number 2. Wyatt and Marla left home. Let me see if I can get this to not look quite so shiny. Oh, it doesn't matter, does it? Yikes. Well, I'll read it to you. Oh, there, that's better. Okay. Wyatt and Marla left home on their bikes. They were meeting at the library, which is the same distance from each of their homes. Wyatt traveled at a rate of 20 miles per hour every 2 hours. Marla traveled 6 miles per every 0.5 hour or 1/2 hour. Okay, who arrived first? And then your last problem. Seems better if I move it down here. There, that's better. All right, number 3, convert 4 miles per hour to feet per hour. Okay, so problem number 1. We've got a simple motion rate here. So if Olivia's family traveled at a rate of 60 miles per hour, that's 1 hour. There's your unit rate. Whoops, sorry. Hold on just a second here. I need a multiplier. I forgot we're not really setting up a rate on this kind of a problem. All right, so I'm just so used to setting up the rates as fractions. So 60 miles per hour. So that means we're going to multiply 60 times how long they were driving. All right, so 2 5/10 or 2.5, 2.5 hours. Right? So that gets us 150 miles. Okay, and so you should have a sentence here too. This should have a answer sentence. Olivia's family traveled 150 miles. All right. Okay. Next one, Wyatt and Marla. We need to compare these rates that they did. All right. So comparing. Let's set it up first for Wyatt here. Wyatt was traveling at 20 miles for every 2 hours. Okay, so what is that in a unit rate? So 1 hour. Well, I know I have to divide that by 2, top and bottom. That means he was traveling at a rate of 12 miles per hour. Or I'm sorry, 10 miles per hour. All right, so now let's see what Marla was doing. Marla was traveling at 6 miles for every half hour, or 0.5 hour. We need to convert that into a unit rate of 1 hour. So divide that by 0.5, top and bottom. And so that doubles the 6 to a 12. When you divide it by 0.5, that doubles the 6. So she was traveling at a rate of 12 miles per hour. So who is traveling faster? Well, Wyatt in an hour can get 10 miles. Marla in an hour can get 12 miles. So she must be traveling faster. So Marla got there first. I could probably write a better sentence. I'm just trying to hurry. Marla got there first. Okay? All right. Now, conversion. Let's see what we remember about how to do the conversion. All right. We set up the original rate. It is 4 miles, okay, per 1 hour. Now we're going to multiply that by some multiplier. We don't know what it is yet. And what are the units we want at the end? We want feet per hour. Okay, so which one of the units here do we want to get rid of? Well, we don't want to get rid of hour. That's in our final answer. We know that. And so the one we want to get rid of is mile. And to be able to cross cancel that, we need it to be diagonal from the mile. So we know feet has to be up here, and that means then that we need 1 mile. Well, how many feet are in 1 mile? 5,280. All right, so that canceled out our miles. Now we have 4 times 5,280. Boy, we got a lot of feet now. It's 21,120. And 1 times 1 is 1, right? So 4 miles per 1 hour is equal to 21,120 feet per hour. There's our conversion. All right, so that's your practice problems. Let's take a look at your worksheet. On the worksheet, the problems 1 and 2 are pretty much like the first problems we did in our notes. Nothing too terribly difficult there. You just figure out what you're going to multiply by. Follow the steps on example A. On these two, they're asking you, let's make sure you're sure of what it is they're asking you. They're asking you to figure out what's the faster rate. So you're comparing rates, which means you need unit rates. Sometimes it's already a unit rate. That makes it easier for you, but they must both be unit rates in order for you to compare them and figure out which one is faster. Same thing is happening here. You're going to set up a rate and convert it to a unit rate for Austin, and a rate, convert it to a unit rate for Jill, and figure out which one is faster. All right, now on 6 and 7, this one is kind of confusing. Now we're talking about converting units to units, like we did at the end of the lesson. So on this one, they're not asking you to complete anything on these. Look at number 6. They're asking you which one of these, A or B, would you use as your multiplier to get from miles to hour to feet to hour. So remember, if you need to, you got to look first, what do you want to keep? You want to keep hour. I see it in my final. Okay? And so I don't see miles in my final. So it's miles I want to get rid of. And miles as a unit I can only get rid of if they are diagonal in a rate fraction that I'm working with. So keep that in mind when you try to figure out, is it this one or this one I would use to get from here to here. Okay, and then number 8 and 9, they're just like the ones that we did in our final examples in our notes. So it's kind of confusing because they go directly from rate to rate without showing you the times something. So I would write this out if it were me. I'd say 3 miles to 1 hour times something equals, okay, and they're telling you feet to 1 hour. Okay, I would do it like this. That's how it is in your notes, and that's going to make it easier for you to figure out what is my multiplier that's going to help me cancel the units I don't want in my final answer. Okay, set both those up like that. All right, so that is your worksheet. That leaves us with your exit ticket. Exit ticket for lesson 2.6. Extra practice. Looks like there's one example of each kind of the problems that we've been dealing with in this very long lesson. If you're comfortable with all 3 of these, then you are ready to go. All right, so that's lesson 2.6 out of the Rates, Ratios, and Statistics book. Remember, the only way to learn math is to do math, and mistakes are proof that you're learning.